Okay, let's look at this question and how do we solve this. Find the gradient of a line that is perpendicular to 8y plus 4x equals to 5. Now, from the equation, we know that this is a straight line. Why? Because it consists of linear terms. Okay, and the key word that we should look into is perpendicular. So we want to find the gradient of one line that is perpendicular to another line. So this will come back to the basic concept that when a straight line 1 perpendicular to straight line 2, their gradient m1 times with the gradient m2 will always equals to -1. That means if I know m1, I can find m2 by finding the negative of the reciprocal of the m1. In other words, if m1 equals to 3, m2 will equals to the opposite sign, which is negative, and its reciprocal, 1 over 3. If m1 equals to -5, m2 will be the opposite sign, which is positive, and its reciprocal, which is 1 over 5. Okay? If m1 equals to 3 over 4, and therefore m2 will be the negative, the opposite sign, which is negative here, of its reciprocal. 3 over 4 will become 4 over 3. If m1 equals to -2 over 3, therefore m2 will be the positive sign, because negative times the -2 over 3 will be positive, and its reciprocal, 3 over 2. Okay, so this is the shortcut to get m2 from the m1 if both lines are perpendicular to each other. So in this question, we have one straight line that is perpendicular to the given straight line, which is 8y plus 4x equals to 5. And because of perpendicular, and we need to find this m2, therefore m1 must be found. How do we find m1? We have to rewrite this equation in the form of y equals to mx plus c. This is the gradient form because it tells us the gradient. Therefore, let's rearrange this. 8y equals to 5 minus 4x, and y equals to everything divided by 8. So we have 5 over 8 minus 4 over 8x. And therefore, our m1 will equals to -4 over 8, which after we simplify, it becomes -half. And with that, we know that m2 equals to -1 of m1, because m1 times m2 equals to -1. Basically, we don't need to show. We just use the opposite of the reciprocal, the concept. So if we have m1 -half, m2 must be +2. So that is the answer. All right. So let's move on to the next question, which is question number 15. Now, question number 15, we are given a speed time graph. That means the speed versus the time. All right. So if we are given a graph, we have to understand the way to analyze a graph. So to analyze the graph, we have two ways to look into. One is to find the area under the graph. Another one is to find the gradient of the graph. So area under the graph, in this case, we take the length times the width, or any shapes, the polygon that is involved, it still involves the base times the height. So we just take that. So the base is in terms of second, and the height is in terms of meter per second. Therefore, if you multiply this, and you will have derived the unit in terms of meter. That means for the speed time graph, if we find the area under the curve, we will get the displacement, or the distance traveled. Whereas the gradient will be the height by the base, isn't it? The height by the base, and the unit for the height is meter per second. Okay, let me write like this: meter per second. And the unit that involved in our time is in second. So let's derive the final unit for our answer. That will be meter per second squared. Okay, because -1 minus 1 here, use the concept of index. Therefore, from here, we know that this is actually the unit for acceleration. So just nice, we can find A, because A, we are asked to find deceleration of the car between 60 to 100 seconds. So 60 seconds is over here, and 100 seconds is over here. Okay, so the corresponding time, the coordinates is 106, whereby this is 60 and 18. The coordinate y tells us the speed. So the deceleration, based on our analysis, the way we analyze our graph is can be found by looking for the gradient. So gradient, in this case, we take it's a negative gradient, okay? So the gradient is equivalent to our acceleration. And because this gradient is going downhill, so we have a negative, or you can just use the coordinates to find. All right, so we have 6, y2 minus y1, so 6 minus 18. Okay, x2 minus x1, so 100 minus 60. So over here we have negative 12 over 40. So the answer will be negative 12 divided by 40, 0.3, negative 0.3. Okay, negative 0.3. And this is acceleration. Our acceleration equals to negative 0.3. So the negative indicates that this is a deceleration. The question says in words, deceleration, finding the deceleration. So we just give the positive value. Maybe if you're not confident enough, you just write deceleration equals to 0.3 meter per second squared. Okay, so this is how we find the answer for part A. All right, so part B, calculate how much further the car traveled than the motorbike during that 100 seconds. So over here, we have motorbike that travel at the constant speed. So to find the distance of the motorbike, you just need to find the area under this graph. Okay, let's find out the distance by the motorbike. Okay, distance by the motorbike, that will be, see the distance in meters. So we take the area under the graph. So that will be 12 times with 100. And that will give us 1,200 meters. What about the distance by the car? Now, the area under the graph basically is this whole thing. So it consists of one rectangle and one trapezium. Okay, one rectangle and one trapezium. So let's call this part A and call this part B. Therefore, let's find the area for part A plus the area of part B. The area of part A is a rectangle, so we just take length times the width. So 60 times 18 plus the area for the part B, which is the trapezium. So half times the sum of two parallel sides. The sum of two parallel sides is actually this and this. So the value will be 6 plus 18 and times with the distance between these two parallel sides, which is 40. And therefore, let's use our calculator and get the value. 60. Okay, we have 60 times with 18, which gives us 1,080. And then plus this one, we can simplify first 20. All right, so we take 6 plus 18 times with 20. So 480. So you add this together. That will give us 1,560 meters. Therefore, the difference in the distance travel will be taking the higher one minus the lower one, and the unit is in meter. So the answer will be minus 1,200, 360 meters. That is the difference. Okay, all right. So let's move on to this. Number 14, work out this one and give our answer in standard form. We're going to show the working. Now, for this question, we always take out the highest common factors. So the highest common factors, you see the common factors, I got 10 to the power of 199, 10 to the power of 201. I shall take 201 as my factor. But before I factorize that, I have to make sure I see my 10,000 and, 10 to the power of 201 in the first bracket. So let's rewrite that. Okay, 10 to the power of 201. However, the original is 199. So isn't it 199? We have to minus, okay, minus another 2. Okay, that means we got to times with 10 to the power of negative 2 so that we get back 199 for the first part. Okay, and then plus 2 times 10 to the power of 201. So now for these two terms, both having the same factor, which is 10 to the power of 201. Let's take that out. Okay, let's take that out. Therefore, we will take that 10 to the power of 201 out. So the first one will left with 3 times 10 to the power of negative 2 and then plus 2. The second one will left with just plus 2. And 3 times 10 to the power of negative 2 is actually 0.03. 1, 2, and move to decimal place. Plus 2 times 10 to the power of 201. So we got 2.03 times 10 to the power of 201. This is the standard form. Or you can choose to factorize 199 instead. So 3 times 10 to the power of 199. But we have to rewrite the second part. Instead of 10 to the power 10 to the power of 201, we want to see 199 also. How do I get back 199 to the original 201? I plus 2. That means I times 10 to the power of 2. So now let's factorize the 10 to the power of 199 out. So the first term will left with 3, and the second term will left with 2 times 10 to the power of 2, which is 200. And therefore, let's add this together. We have 203 times 10 to the power of 199. Yet, this is not the standard form. The standard form must consist of a number between 1 and 10, not more than that. Okay, therefore, I've got to change this one. This one can be written as 2.03 times 10 to the power of 2, and then times 10 to the power of 199, whereby common base, we can add together the index. We have 2.03 times 10 to the power of 201. We get the same answer as this one. All right, so that's it for this part.